Okay, thank you, people. Welcome to this is the first meeting to share about the things we are doing in the university and just to promote or get involved with the students into the cloud native ecosystem. So this time we are going to show you a project that is basically a distributed system for to show our real-time information and is related to the COVID-19. We are using Linkerd and another cloud native technologies. So let's get started. Well, Charles, maybe you can introduce yourself.
Yeah, hi. My name is Charles Pretzer. I work at Buoyant and I'm part of the Linkerd community. And so I've been working with Sergio a little bit to put together some content. So I'm really excited to see what you all have been working on in your project.
Okay, thanks. Well, this is me. I am Sergio Mendez. I am professor here at the University of San Carlos of Guatemala. So I am trying to show you what we are doing with my students. Um, Christelle, are you there? Okay, so well, Christelle is another student that is going to present some content in these slides. Victor, are you there?
My name is Victor Lopez. I am a student at University of San Carlos. I am 30 years old. Thanks.
Okay. Nelson, maybe you can introduce yourself. Alessandro.
Hi, my name is Nelson Gonzalez. I'm a student of University of San Carlos of Guatemala. I'm currently on my eighth semester, and I'm happy and glad to be here today.
Nice, nice. Juan Pablo Estrada.
Hi, my name is Juan Pablo Estrada. I'm 21 years old and I'm very happy to be here.
Nice. Luis Vargas.
Hi to everyone. My name is Luis Vargas. I'm 22 years old. I'm in my last year of the career here in San Carlos University.
Nice, nice. So what is this project about? So basically it's a generic distributed system architecture that shows statistics on real time using Kubernetes and cloud native technologies. Well, we are using Linkerd, gRPC, and other cool technologies. So basically, we are doing like a kind of blue green deployment, or doing like a kind of canary deployment and some traffic splitting using service meshes. In this case, we are using Linkerd. This project will tries to show some information in real time about COVID-19 cases around the world. So basically, it's a real time display for real-time COVID cases around the world. So the objectives of this project is to understand the concurrency and parallelism theory of how to develop distributed systems. That is very focused on the course of operating systems in the university. We are trying to experiments with the cloud native technologies. So in this project, we are focusing more on the service meshes technologies and the Kubernetes to create a distributed system. We are trying to design or to use different system strategies or for distributed system strategies to improve the high concurrency and to improve the response of the technology. We are using an orchestrator. In this case, we are using Kubernetes to create this system. We are trying to perform or to give to this system some reliability, some performance that you have in the high availability systems. So the cloud native technologies that we are using right now. So, Christelle.
Hi and good afternoon. What is Kubernetes? It's a powerful container orchestrator that gives you the ability to create a distributed system, scale it, and manage every container inside it. It focuses on declarative definition of objects and guarantees the state that you define for each object that you create inside the cluster. In other side, it offers features that give you the power to create CI/CD pipelines, complex deployments focusing on DevOps practices.
Okay, nice.
And what is Linkerd? Linkerd is a service mesh that is ultra lightweight. It is simple to use. It gives you the ability to secure your microservices, implement observability, and other functionalities related to service meshes. It is 100% open source.
Yeah, so
Thank you.
that's like kind of the main technology that we are using right now with Kubernetes. Um, so gRPC.
What is gRPC? gRPC is an open source, high performance RPC framework that can run in any environment. It can efficiently connect services in and across data centers with pluggable support for load balancing, tracing, health checking, authentication. It is also applicable in last mile of distributed computing to connect devices, mobile application, and browsers to backend services. It's implemented in different language as Go and Python.
Okay, nice, nice. And the Prometheus.
Prometheus is an open source system monitoring and alerting toolkit original built at SoundCloud. Prometheus's main features are a multi-dimensional data model with time series data identified by metric, name, and key value pairs. PromQL, a flexible query language to leverage this dimensionally, and other features for monitoring this kind of data mode with time series.
Nice, nice. Grafana.
Okay, Grafana is a software tool that is used to compose observability dashboards with everything from Prometheus and Graphite metrics to logs and application data to power plants and beehives. You can find a live demo at grafana.com and other information about it. Next, we have Locust, which is an open source load testing tool. You can define user behavior with Python code and swarm your system with millions of simultaneous users. And also is the link at locust.io.
Nice, nice, nice. And finally, the NoSQL.
These are no relational database. In this case, we are using a documental and a key-value NoSQL database to perform fast and unstructured data real-time processing. There are some technical advantages, such as they are distributed, some are scheme-free, and query data really fast.
Nice, nice. So in general, that kind of technologies are the cloud native technologies that we are using in the project. So maybe I can explain a little bit the whole picture of the architecture that we are using and how they are connecting each other. Um, so let's start it in this part. Well, we are basically implemented two types of how to send the traffic in the system. So, well, we are using Locust to generate the traffic in a massive way. So basically, we are reading a file that contains a lot of JSON information and send randomly, or let's say send some information between an ingress controller, in this case, Nginx. So we implement basically a traffic splitting. So we create two versions or two sites where all the traffic goes across the whole system. So in the first part, and this is described in the blue color, You can see that we are using the gRPC technology. So the goal maybe is to compare how the traffic distributed, and they compare to gRPC against Redis. So in the side of gRPC, basically we implement a client server architecture just to send information and publish information into the NoSQL database. We are using here the part of Linkerd to split the traffic 50% in the side of gRPC, and the other 50% using Go and Redis with the PubSub algorithm. In both sides, they insert data into Redis and an SQL. In this case, is MongoDB. Yeah, in this part, when it's the second part in the green part, we are using the PubSub algorithm. So we are trying to implement like a kind of a small broker system using this algorithm that Redis implements already. And we insert the same kind of data into the MongoDB and Redis. All the traffic passes across Nginx, and we are splitting the traffic again. And in this side, we are using the observability layer, let's say that, with Linkerd. We are splitting the traffic in one side, and in the other side, we are implementing some observability in the different microservices that we are using. In this side, we'll Linkerd use Prometheus to storage these metrics and show some graphics in Grafana and some information in real time using the dashboard. And finally, well, the technical approach of the service meshes in this project, well, we are trying to collect some golden metrics, the latency, requests per second, and we are doing traffic splitting. We are trying to show the traffic on real time. So this is the way to provide like a kind of observability in a simpler way without modifying the code. And in the other side, we are trying to secure our microservices using the TLS capability of Linkerd. So in that way, we can secure our microservices. And well, this is like the kind of the cloud native technologies that we are using, just exploring the different kind of technologies on that part. And finally is the cloud provider side. In this project, we are using, of course, well, we are using Google Cloud, the GCP cloud provider. And well, we have some instances where we store some data, MongoDB and Redis. We use some kind of serverless technology using cloud functions on Google Cloud. And in the other side, we are using Cloud Run just to use like a kind of container as a service service in this cloud provider. Basically, in that part, we implement a UI just to show the analytics on real time. We are using the WebSockets technology using Node.js that requests some, let's say like every 5 seconds or 3 seconds, some information to the MongoDB. And so this UI consumes the data that is stored in MongoDB, and there's another report that is stored on Redis. So the way to access that information into the Redis database, we use a serverless function just to expose the students to the different kind of technologies. In one side, the open source technologies, let's say Kubernetes, gRPC, the PubSub, to expose the student to the NoSQL databases because are very common in distributed systems or in the high availability systems. We also explore some different services that are very common used in a cloud provider like Google Cloud, serverless technology, container as a service, services like Cloud Run. And in the other side, we are trying to implement some like kind of best practices or some kind of DevOps workflow in this project just to experiment about this information. And basically we are using Python for some data generation, Go just for really fast data processing, and some kind of algorithms that very commonly used in the operating system theory. So basically that's the whole picture, that you input some data, goes across to the ingress controller. So the Kubernetes cluster process the data. In one side, you can process the information using gRPC. In the other side, you can use Redis, the PubSub algorithm, to process the data. The data is stored into the NoSQL databases, one a key value and another a documental NoSQL database like mongodb. And finally, we expose the students to a cloud provider services technologies, like in this case, serverless and some containers. So let's continue with the demonstration. So basically, what are you expected to see in this demo? Well, we are going to explain how Locus generate the information. We are going to show you the data in real time in a website that shows all the information that is processing in real time. Maybe a walkthrough on the cloud functions, maybe on the cloud run. Where is this database stored? Some parts of the code of this project, how gRPC interact. Well, in the final step, well, Linkerd showing the Golden metrics and how Linkerd shows the traffic splitting in real time. Oh, sorry. So let's go with the demonstration.
Hi to everyone. I'm going to show you with Victor the presentation of the demonstration of the application. So Victor, can you share your screen? And we start.
Okay. I give you a co-host permissions, Victor. Oh, let me stop my share. Maybe you can share your screen, Victor.
Okay, there we go. First of all, as my professor said, we're going to demonstrate how we generate traffic with Locust. Locust is an open source load testing tool. So in this case, we are going to simulate, well, not simulate, generate 100 users with a spawn rate of 2 per second to our host, right? That is the where we split the traffic. So start, Victor, thank you. Okay, now, as we can see, we started the generating the traffic to our website, and we can see the graphics that of the data that is stored in MongoDB, the NoSQL database. We can see the infected areas, for example, here, and in the top, Guatemala City, Zacatepec, that are departments of Guatemala. We can see the top 3, that is the count of cases for each department. In this case, we clean up the database for these demonstrations. Now we're going to check the Redis data. In this case, it is the same data that we have in MongoDB, because it is a split traffic, 50% to gRPC and the other 50% to Redis, but at the end we had 100% in each database. For example, here we can see in a bar chart the infected age range and the last 5 infected cases that were registered in the Redis database. So now how we created this, we used a GCP, yes, in Google Cloud, and we use cloud functions. We use one cloud function that is the one that connects our website that was developed with React, and we're going to wait with React, and our cloud function that was developed with Python in a cloud function. Here is, as you can see, here we have our function. Source, go to source. In source, we can, no, it was developed with Golang, sorry. And here we have the connection with the database, with the Redis database. And here we get the data and obtain the data. And we used also Cloud Run, that is a container as a service that provides Google Cloud. And there we implemented an OGS API that implements sockets.io that connects the data in MongoDB with MongoDB with Node.js in a second. As we can see, refresh the page, please. Refresh. Well, we used Mongo Atlas to store the data. Now, there it is. And Redis, we used a compute engine machine, I'll call virtual machine in Google Cloud to run the database, the server. And that is all. Now we're going to present the Linkerd part. My professor is going to present it.
Okay, so I think that Nelson has permissions. Alessandro, let me give you the. Oh yeah, maybe you can stop your share. Okay, that's it.
Sorry, I forgot something. We also had well, in the Kubernetes we had two containers that uses the pub/sub Redis technology, publisher and subscriber, to simulate a kind of broker that is implemented in Kubernetes too.
Okay, nice. So as you saw in the past architecture, basically we implement a dummy service, a green deployment, and a blue deployment. So this is the Linkerd dashboard that is really, really easy to use. Basically, when you are using a service mesh, you inject your pod and this pod initially can contain only one container, but when you inject the service mesh functionality, adds another container like a child container that is called like a sidecar. So this sidecar contains a proxy that receives all the traffic. Then this traffic asks what they can do and ask to the control plane that is on the Linkerd side, and then decide what to do. In this case, we'll receive the traffic, split the traffic 15 on one side and 15 in the other. So maybe we can see the split. Let's wait for the traffic. So here in the Linkerd dashboard, you can see the split chart that when you are sending traffic, they split like 50% and 50% of each side. So you can see in the same way the traffic on real time. Well, depending on the resources, maybe in this case, you can see, for example, if the traffic fails, or if there is an error in your network, There's very useful, well, in this case, on this project, we only use the traffic splitting and we inject the traffic. Here in the project namespace, you inject, well, basically the students injected all the pods or the deployments that are already in that namespace. So Linkerd gathers that traffic and show you what is happened and if the traffic is splitting. I don't know if maybe we can open a Grafana dashboard on the yeah, that one. Yeah, let's wait for the graphic. So basically Linkerd is using, well, storage all the metrics using Prometheus, and Grafana really integrates really nice with Prometheus and shows some graphics of all the metrics that is collecting. In this case, we are looking for the requests per second for each microservices and how many pods contains this service, and for example, the success rate, the request rate, latency that is related to the golden metrics. So it's really easy to implement that with Linkerd without modifying into your code. So in this case, for this project, we use the part of recollect the golden metrics like success rate, request rate, latency, and the other part for the traffic splitting. So basically, it's that all the part that the project contains a very really nice dashboard, and maybe we can see only one service, maybe the gRPC client in the Linkerd, the gRPC client. Yeah. So in this case, well, Linkerd can show you, well, if the service is healthy or not, the request per second in real time. We can see the live calls that show you sometimes the requests that are on real time. So, well, you can use another features like tap and other things. Well, that's basically that service mesh does with this project. So that's it. Maybe I don't know if Nelson or Luis wants to add something to this.
For me, there are no comments. Yeah, I think that it is all in for me.
Okay, nice. So maybe we can continue with some Q&A time. Let me share my screen again. Okay. So where's the slides? Where are the slides? Sorry. Okay. I think that oh, here is it. Sorry. So basically, well, the conclusions of this project. Well, at the beginning, we have like 5 objectives. So experimenting with these technologies, this is the conclusions. So Kubernetes provides a ready platform to implement this kind of distributed systems that has high concurrence. So modern cloud native technologies provide like a kind of blueprint to develop these high concurrency distributed systems. So it provides all the necessary things, the pieces that you need to create this kind of distributed system. Well, in the other side, we are using like a kind of modern way to communicate the microservices. I am talking about gRPC. So gRPC is very powerful, very lightweight. They support a lot of languages to write your code. For example, Python, Go, and that kind of things. So in that way, gRPC is the new way to communicate the microservices on these days. So in the other way, Linkerd provides you the ability to implement observability without modifying your code. it's very lightweight, so you can save a lot of money using Linkerd without consuming a lot of resources. Another conclusion is that, well, after the experimentation, the containers, well, we conclude that the containers provide a way to package all the logic, your applications, and provides you, well, or push you to move to implement some kind of best practices for microservices. For example, slide a monolithic application and split it and slice all this monolithic application into small services that communicate each other. Let's say this microservices architecture in an easy way. So right now we are using Kubernetes, the things, we are using Docker, and in the future, well, we are moving more on containerd because, as you say, well, Kubernetes is moving to support the containerd technology. So, well, the concept is containers and helps to package your application. And another conclusion is like the service meshes provide you a way to measure the high performance and high availability systems without modifying your application. So it's really, really easy to use. So the Q&A, maybe you can enter in your browser the slido.com with the hashtag or the code CNCF students. So maybe we can see if you have questions. Yeah, so maybe you can enter in your browser the slido.com with the code CNCF students, or if you want, you can talk, or you can turn on your microphone and maybe you can ask your question or maybe a comment in this chat of Zoom. Or Charles, did you want to ask something? Yeah, I think that are the challenges for us, the language. Okay. Let me open the Q&A. CNCF students, if you have questions, let me open my slide. Okay, so let's read if somebody have questions.
There is one question, Professor.
Okay.
In the slider.
Oh, okay. Let me read. Live Q&A. Okay. Well, I think, well, this is a question for Charles. Says, does Linkerd support different types of installations like Minikube, K3s, or others?
Yeah, for sure. So Linkerd is meant to run with all certified versions of Kubernetes. And so that includes K3s, K3D, Minikube. We do a lot of development and testing using Kind, which is Kubernetes and Docker. So yeah, as long as it's a certified version, Linkerd will run on that version of Kubernetes.
Oh, nice. So I don't know if somebody want to ask something. Maybe Florent, maybe you want to ask something, or
Yes, I was just asking how long did it take to implement such architecture with 5 students?
sorry. So the question is like, oh, okay.
It is for us.
Oh, okay. How long? Oh, how long? Well, just to design the architecture is more like, where like, I don't know, maybe a time of inspiration. But well, the time that the students took to create this project was like maybe 2 weeks, 2 weeks per se, more or less. But behind that, we did some workshops of Kubernetes in the class. Well, let's say that this December we had an intensive course that only dures 1 month. So during the second, well, let's say the first week and the second week, the first week we explored the virtualization technologies, and we did some Docker workshop that includes build images and well, build images, use Docker Compose just to compare the Docker Compose with Kubernetes them. And then the other week, I remember that they took like, I don't know, maybe 3 days with the workshop of Kubernetes. After that, we present the project to the students, and they took like maybe 2 weeks to create the whole project and test the thing. So the date present the project was the last week on Friday. The project that you saw here are like the best projects, the best two projects. So there are like 4 or 5 guys here talking about their project. So yeah, let's say that maybe 1 month to be prepared and to build the whole project. Well, this project was built with 3 students per team. Well, so yeah, more or less like, let's say 3 weeks to explore, to learn the technology, and to understand the concepts behind. So yeah, pretty much like 3 weeks.
Teacher, I have a comment about that. In my case, that I'm a student, I didn't know. I haven't implemented Docker containers or a Kubernetes orchestra 1 month ago. So this was my first time implementing this. And in the case of most of my classmates, I think that it was the same. Just 1 month of everything.
I don't know if Nelson, you want to try to share something about your experience doing this project?
Yeah. Well, for me, it was like a shock, at least at the beginning when I saw the old architecture, because there were so many technologies to learn in such that little time, I think.
No, nice, nice. Yeah, so
But it
yeah.
also came together. It also, and yes, that's all.
Okay, so yeah, I think that for my students and for me, it was like a big challenge to teach all these crazy technologies that is very powerful in the same way. So, well, for me was, well, we're trying to integrate another kind of technologies for observability like Jagger, let's say, but I choose Linkerd because, well, we can teach only a small part, some very basic concepts to understand how the observability works. So basically, we choose Linkerd to experiment in this time. Well, this is the result of the job of 1 month, let's say. Yeah, that's it, more or less. Charles, maybe you can say something, or what do you think about?
Yeah, no, this is a very impressive project, especially the fact that everybody got it done in 3 weeks. So, if I remember correctly, Sergio, you said that this is this is for the winter session, right? So this is a shortened session,
Yeah.
opposed to the regular semester, or whatever. That's really impressive. I think you all should be pretty proud of yourselves with the work that you've done. And cloud native technologies are not easy to learn. There's so much to learn in there. And so to be able to understand Kubernetes and to implement each of these different technologies to put together a working application, it's really, really impressive. There's a question on Slido that Wilson asks that about the proxy being completely replaced in Linkerd 2. And so Yeah, the history there is, and the next question is, what kind of improvements did you notice after changing the original proxy for one developed in Rust? So the context for that is that Linkerd 1 was written using Scala and ran in containers on the JVM. So what that allowed it to do is run everywhere, even outside of Kubernetes. The trade-off there, though, if you're familiar with Java and the JVM, is that it's very resource intensive. So it wasn't really realistic for, as things became more distributed, as applications became more distributed and people were running in containers instead of on VMs, it became difficult to run the JVM Linkerd, the original Linkerd, inside of a Docker container. So the team went and they completely redesigned Linkerd. So Linkerd 2 is the version that you all are using now. And so while it is restricted to running in Kubernetes, the trade-off there is that the Linkerd 2 proxy is written in Rust, which is a much faster compiled language that is it runs closer to the metal, right? So you're almost programming directly against the system API calls. And the team chose Rust. They looked at Rust and they looked at C, but they decided to use Rust because it is type safe and memory safe and still provides really, really tremendous performance. And so that answers the question here for Wilson, is that by using Rust, the proxy is much more performant. It's much more reasonable to deploy the containers within another pod inside of Kubernetes. So that's a really good question. If you all are interested in learning Rust at all, the Linkerd proxy team has a lot of experience with it, and there's a Linkerd proxy repository that you can check out as well. So that was a lot. If there are more questions, I'm happy to answer those. But yeah, this is a really cool project. I'm curious to know what you all learned about. Were you able to get any information about the spread of COVID from your project?
Well, right now it's like random information, but well, the goal was like create a real time system to fill from real data, let's say. So yeah, it's like random information. It's not like real information, but you can use real information to show some real graphs. Um, yeah.
Yeah, that's really great. Well, I hope that it would be great if, since this is an open source project, that maybe somebody could use this and do something that's helpful.
Yeah, for sure. So let's continue with, I don't know if there's another question, so maybe we can move to the final part, or
Professor, in the slider, there is another question.
really? Let
Yes.
me let me see. Okay, thank you so much, Wilson.
From Florent.
I I can read.
I'm
Oh,
gonna
okay.
read it for you if you want. Or no?
Yeah, go
Okay.
ahead.
Okay, it is what was the main motivation behind using MongoDB instead of GCP data store?
Okay, that's for me. Yeah, so I know. So, well, data store, or well, the goal here is that in the distributed system, they are very common to use like NoSQL databases. So in this case, to expose the student to use NoSQL databases instead of, let's say, like a kind of a relational database, or so that's the goal, to expose the student to a NoSQL database in general. Yeah. So I know, well, for a real use case, we have to evaluate the speed of the database and that kind of things. But let's say that this project has the goal to expose the student to a different technologies that are very commonly used for distributed systems. So in this case, the NoSQL has some relationship with distributed system, like the map reduce concept behind to read and process data. And that's the reason to choose an NoSQL database. In this case, MongoDB is like free of schema. That's very simple to use, like just because this is a course of operating systems, no database course. So, well, in this case, MongoDB is like really perfect for this purpose and like a first step to experiment with NoSQL technology. So that's the general reason to choose MongoDB. And that was like something special. But MongoDB in the end has a really nice performance. So that's really perfect for this project. I don't know if that can answer the question of Florent.
Yes, she said thanks in Slido.
Okay. Okay, so yeah, let's end the meeting. Oh, sorry. Well, we already have here in Guatemala Cloud Native Meetup. So this is the link if you can join. Well, there are like two ways to join this meetup. Well, for people who speak Spanish, obviously, because here we are here in Guatemala. But I have some friends that use my meetup to learn more Spanish, so could be an option too. We are trying to involve more the students into this cloud native technology, so you could expect as an assistant that or an attendee that we are going to do more meetups in English. So maybe you can share us that way. You can contribute to this project. Maybe somebody's interested in share know more about this project or create an issue, giving ideas. You can find this project that we are already presenting here at my GitHub, and this is the link. Maybe you can take a screenshot. Um, I think that maybe I can send an email with the URL of the repository. But if you are interested in contribute to this project or give the next idea for a different project using distributed technology, cloud native technologies, you can post an issue on this repository. So I really appreciate that. um if you are the professor or I don't know, well, you can use this hashtag, the CNCF students, to promote the students into the CNCF ecosystem. This is like the kind of the first drive to get involved with the students into the CNCF. So we can reproduce this movement using this hashtag. This is something new. I am trying to promote this with the CNCF guys. um well, here, yeah, you can join the CNCF Slack channel. We have a specific channel for students, the hashtag students. You can join the CNCF channel. You can join us there, share with another professor. If you are a student and you are interested on that part, you can join us. This is Slack. And Charles?
Yep, I'm here.
Yeah, maybe you can invite the people to the Linkerd community.
Yeah, for sure. We'd love to have you become part of the community and come help us out with some of the work that we're doing. I'm always on Linkerd Slack, so if you want to come over there and ask some questions, you can register at slack.linkerd.io and have a conversation. I can answer your questions. We can talk more about cloud native architecture and how Linkerd fits into there. And the Linkerd Twitter account is always posting updates about service mesh concepts and when we have new releases of Linkerd. And then if you really want to get involved, check out our GitHub, and that's where you can find out about becoming a contributor and do things like help us out with the documentation so it's clear and everybody knows it's easy for everybody to use Linkerd. So yeah, I really appreciate all of your time and effort on this, and really great job, everyone.
Thanks. So, well, I think it's the end. So, well, thank you very much, people, to share with us. That's like the first step to get involved students in your country and in other place, and well, to learn this cloud native technology. So I really appreciate your attendance and thank you very much. So we'll be getting in touch. There are more events coming, more students events coming, and new technologies and that kind of thing. So thank you very much. And yeah, thanks, Florian, for your attendance. Thank you very much. Thank you, Catherine, and all the students here. That is your effort, is your way to expose your work in the university and get involved in these new things and open your eyes to another cool things that is in the software world. Um, and thank you very much.